Hi, everybody, and welcome to Just Equation's first webinar, the Architects of Math Opportunity, Equity, and High School Math Pathways. I'm Jen Bavard. I'm the Just Equations project manager. And today our webinar is going to be hosted by Pamela Bergman, our senior project director and founder. And Robert Kuberi III, the president of the National Council of Teachers of Mathematics, and Phil Darrow, who's a co-author of the Common Core State Standards for Math. Before we get started, just a couple little housekeeping items. When you'd like to ask a question, please make sure you use the Q&A button on the bottom of your screen. And feel free to submit your questions throughout the webinar. The panelists will get to as many as they can. And we will be sending a follow-up email with a link to access the webinar recording in the coming days. And with that, I'm going to hand it over to Pam Bergman.
Whoops, sorry about that. Thank you, Jen. I'm Pam Bergman, and before I introduce our guests, I'd like to say a few words about Just Equations and our Mathematics of Opportunity framework. Just Equations is based in Berkeley, and we are a project of the Opportunity Institute. We are focused on reconceptualizing the role of math in ensuring education equity. We are currently in our second year, thanks to our funders, the Irvine Foundation and College Futures Foundation. We are grounded in the values of evidence to ensure effectiveness of policies and practice, equity to ensure that demographics don't determine your math destiny, rigor so that all students acquire quantitative literacy in meaningful ways, and alignment to ensure that arbitrary requirements and disjunctures do not limit student success. Our framework highlights the prevailing architecture of math opportunity, which is undergirded by misconceptions about math ability, about who can and can't learn math, as well as what learning math is really all about. It's scaffolded by existing inequities and stereotypes that affect many students in their educational progress, particularly students of color, low-income students, students with disabilities, second language learners, etc. And it's reinforced by math's use as a marker or pedigree that confers access to opportunities. So we're focused on changing this architecture as a key to advancing equity. And we see this as occurring across four interrelated dimensions: content, instruction, and assessment, which, as you see, are braided together. These practices are braided together to inform policies, the math readiness policies and structures that determine how math confers access to opportunity. We look at, and our project looks at three areas of math opportunities: high school math pathways, post-secondary admissions policies, and post-secondary math pathways. And our focus for today is on the first, redesigning and rethinking high school math pathways. So with that, I'm going to introduce our panelists who have a lot of insight to share on this topic. So joining us from his office in Virginia, Robert Berry, president of NCTM. He's also a professor of education at the University of Virginia. And I was excited to discover he was twice named Teacher of the Year in Virginia. He's going to talk to us about the recommendations issued by NCTM last year in a groundbreaking report called Catalyzing Change in High School Mathematics. If you haven't read the report, you really should. It's a terrific report. We're going to provide a link at the end of the webinar. After Robert speaks, we're going to hear from Phil Darrow. Phil was one of the principal authors of the Common Core State Standards in Math, and he's been involved with research and professional development related to math education for several decades. And he continues to be involved in implementation and policy issues related to the Common Core. Phil is going to reflect on the Catalyzing Change recommendations and converse with Robert about the implications of implementing them. And then we will also respond to as many of your questions as we can. So please send your questions in whenever they occur to you. So with that, Robert, you're up.
All right.
Just one moment. There's a little bit of a delay here.
Okay.
So thank you so much.
Go ahead, Robert.
All right, good. Thank you so much, Pam. And I appreciate everyone joining in on the conversation. I'm just going to talk about a publication that NCTM put forward in April of 2018. And it results from a task force that focused on high school mathematics, teaching and learning, and looking at some of the issues that impact high school mathematics. And so this report was called Catalyzing Change in High School Mathematics, Initiating Critical Conversations. And the goal for this report was really to engage folks in a conversation about some of the issues that impact students' experiences in high school mathematics. Let's see, I'm trying to go forward here. So the question now is so why catalyzing change in high school mathematics? And partly because when we look at elementary and middle school, we've seen over the last 30 years a steady improvement in achievement as measured by NAEP. The slope is not as steep as we want it to be, but there has been a positive, steady improvement in achievement as measured by NAEP in high school mathematics. But when we look at that same trend for high school, for elementary and middle school from my previous statement, when we look at that same trend for high school, achievement lines have been relatively flat, and it continued to persist. If we can see from 92 to 2012, and even in 2016, that achievement line has been relatively flat. And so the question is what can we do to impact high school mathematics? And what are some of the challenges that impact achievement in high school mathematics? So there are a couple of things that come up. One is when we look at the focus and the standards at K-8, K-8 standards seem to have a little bit more focus. And when you look at even the Common Core, you have the critical areas of focus, and the NCTM has talked about the curriculum focal points. But there's some more focus on the standards in a way that we don't yet see in high school mathematics. And the other thing, there's a lot of content in high school mathematics that teachers have to cover. And so given the sheer amount of content, that can be a challenge for many high school teachers. So there are 4 key recommendations that come forward in Catalyzing Change. And these are the 4. We focus on the purpose of learning mathematics and the essential concepts, equitable structures, equitable instruction, and a common essential pathway. And what I would like to do is just unpack these 4 recommendations as we move forward. So the first one is this idea of the purpose of high school. Did I miss something? Well, there may be a little bit out of order here. So this first one I would focus on is issues around equitable structures. And equitable structures, we're talking about this issue of tracking in high school mathematics. And the issue of NCTM calls for the discontinuation of teacher tracking as well as student tracking. And when we think about tracking, we're really thinking about these issues where marginalized students typically experience the least qualified teachers in a lot of cases and have access to the less rigorous mathematics. And so we want to see how do we broaden the space to broaden participation in the rigors of mathematics across for each and every student. The other thing when we think about tracking for teacher tracking, we focus on the space where we want to distribute the responsibility in high school mathematics department across a broader spectrum of teachers. And so in some cases, there are teachers who are the calculus teachers, and they're solely focused on students who are in that track. But what if we had teacher assignments where a teacher is assigned an entry-level mathematics course and an upper level mathematics course. And being assigned an entry in the upper level mathematics course distributes the responsibility across the mathematics department. And so in terms of the elimination of teacher tracking, we just want to broaden the responsibility, which then might have an impact on who has access to high quality instruction. Another key recommendation that comes out of Catalyzing Change focuses on the space of equitable instruction. And when we say equitable instruction, we're really focusing on these issues of identity and mathematical identity and mathematical agency. We want students to see themselves as doers of mathematics. So we want high quality instruction, but also along with high quality instruction, we want students to be able to see themselves as doers of mathematics. When students see themselves as doers of mathematics, they engage in behaviors that doers of mathematics engage. That means that if I see myself as a mathematics person, then I will do the behaviors or engage in behaviors that high quality mathematics people engage in. So what are some of the instructional practices that we can engage, that teachers can engage to make sure that all students see themselves as being a part of mathematics and studying high quality mathematics in classrooms? And so when we think about this, we want, again, as I said earlier, improving instruction, not only focus on the development of concept and skills, but also having an understanding to empower students to see themselves as capable of doing mathematics. Another key recommendation is the purpose of mathematics. And we identified 3 purposes in Catalyzing Change. One, which is very common, expanding professional opportunities. Certainly want students to have opportunities to experience whatever professional endeavors they see for themselves. A second purpose would be to understand and critique the world. We are critical consumers in our daily lives. We're bombarded with data, whether it's in the social media space or even when we look at the daily news or anything, we're bombarded with data. And so how do we take that data and unpack it in a critical way? How do we help and prepare students to understand and unpack and look at whether or not, whether the data is saying or implying what we hope that it would imply. We want students to be critical consumers and using mathematics to be critical consumers of information. And the third purpose is focused on experience the joy, wonder, and beauty of mathematics. I argue that this is an underserved area. What would it be like if all of our students leave high school with a sense of joy, with a sense of wonder and a sense of beauty about mathematics? Mathematics is beautiful, and like great works of art, what can we do in our experience to help students understand the beauty of mathematics and have an appreciation for that? And also have an appreciation with joy, whether that be persevering, whether that be them engaging in critical tasks that help them understand the connections they see for themselves as they move forward in their lives. So when we think about the purpose of mathematics, we think about these ideas of the essential concepts. In Catalyzing Change, we identified 41 essential concepts for high school mathematics. And these essential concepts are not standards. These are high-level, big ideas. And we argue that these 41 essential concepts should be embedded within the first 2 to 3 years of high school mathematics. And so, as I stated earlier, they're not standards. They're really high-level, big ideas that students should focus on, understand, and develop appreciation for. And so these essential concepts are across 4 content areas: number, pre-algebra and function, statistics and probability, and geometry and measurement. And within these 4 content areas, there are focus areas. So if you see on the PowerPoint here, you can see under algebra and function, there are 3 focus areas under algebra and function: algebra, connecting algebra to functions, and functions. And so you can see the 4 focus area, and then there are the 4 content areas, and there are focal areas within those content areas. And you can see the distribution of the essential concepts across those focus areas and the content areas. So here's a task. And if we take a look at this task and unpack this task in some interesting and critical ways. So this is a task that I found in one of our NCTM publications. And the task is really about a movie theater. So it says a movie theater has operating costs of $1,025 per day. Tickets cost $7.50 each. The movie theater's profit each day depends on the number of tickets sold. You might notice in this task, you see an equation. You might notice that you see a graph, and you should notice that there's a table. When we say the essential concept, we want students to understand the connections among those ideas. How do these different representations connect to one another to deepen students' understanding about mathematics? And so when we say the essential concepts, we're really focusing on those high-level areas and how they connect with one another. And see, on one side, you can see the questions that are related, A, B, C, D, and E, that are related. And so you can see the connection to functions and how we might be able to see how does the table connect to the graph, and then how we might be able to put in some data points to even build more connections. To contrast that, we can see a task that looks like this, where students are solving, looking at solving this equation. So we can see the differences. I showed these two tasks in contrast to one another to help build an appreciation for how with the essential concept, we want students to dig deeper, make connections, and develop understandings. And these essential concepts can be embedded within standards, or standards can be embedded within the essential concept. But the idea is for students to make connections and build deeper understanding of mathematics. So thinking back on the two tasks here, and I've highlighted two areas. And so on the first task, function is described. And so these are the focal areas under algebra and function, and this is the focal area of function. So these are 4 points, or the 4 essential concepts that fall under function. And these two tasks, I hope, highlight these ideas. Function can be described by using a variety of representations. And so the idea of graphs, tables, equations, and then function can be represented graphically with key features of graphs, including zeros and intercepts. So the idea is we can look at maximums and minimums and those things of sort. But the key thing is, how do we make connections among different representations of mathematics, and in this case, a different representation of a function to deepen students' understanding. So another key recommendation that comes out of Catalyzing Change is that we want students to study 4 years of mathematics, and in those first 2 to 3 years of mathematics, that study should be along a common shared pathways that focus on the essential concepts. And what I want to use an example to describe this. So on our screen, we see Oregon proposed model for a 2+1, and we also see a model for Escondido, California Unified High School District model. And when we say a common pathway, if I'm looking at the Oregon model, you see K through 8, but then you see high school content math 1, high school content math 2. This represents a common pathway. All students go through this common pathway, and they're focused on the essential concept that has been applied for math 1 and math 2. After students go through this common pathway, then they have options. They can continue to go through what might be described as a traditional pathway, which focuses on Algebra 2, calculus, and then on to AP Calc if they choose, or on a pathway that focuses on statistics and modeling, or on an applied mathematics pathway. So the common pathway is math 1 and math 2, and then there's some options there. In the same way, we can see for Escondido, we can see the same thing with something very similar, where they have math 1, math 2, and then there's some options after math 2. Math 3 with statistics, and math 3 with pre-calculus, and then students can continue on to either math 4, to statistics, or AP Calc. And so the common pathway is based on those essential concepts, as I described earlier, as students move through and have a deep understanding of the mathematics. So the purpose of catalyzing change is designed to have a critical conversation. And when I mentioned the essential concepts, we identified 41, but there may be different ones or others that localities can have a discussion about. But the key thing is thinking about the impact of not only tracking, but the impact of what are the things that all students should know and understand when they leave high school mathematics, and that can be a local discussion. And then the other key thing is, what would these things look like in a common pathway? So our goal is to have a critical conversation about the impact of mathematics, high school mathematics in particular, on students' outcomes as it relates to how they see themselves in terms of expanding their professional opportunities, understanding and critiquing the world, and experiencing the joy, wonder, and beauty of mathematics. Thank you.
Thank you, Robert. This is Pam. I'm going to remind the participants to please send in questions. Please use the Q&A button at the bottom of the screen as opposed to the chat. Please use the Q&A. And now Phil Darrow is going to share some of his thoughts and talk with Robert about the catalyzing change.
And I'd like to ask you all to share your video as well.
Okay, we will do that.
All right. Does that work? Hello, everyone. So I'm just going to take a couple of minutes first to react to what Bob has described and what the task force, the work they've done from the standpoint of the Common Core standards. When we developed the Common Core standards, we worked under the charge of basing them on evidence rather than on politics. And the evidence came from research, and a lot of it came from comparisons to high achieving countries and other sources. And from all sources, there was one theme that just was extremely loud and clear, and that is that the US curriculum was a mile wide and inch deep. In other words, it had too many topics to cover, putting teachers in the position, and textbook authors and assessment authors, everyone in the system, putting them in the position of having to cover more than there was time to cover. In other words, to rush. And that caused the second part of that problem, which is the inch deep part, which means our content in math, our curriculum, and nowhere is this more true than in high school, is shallow. So we have a shallow specification, a shallow curriculum in high school mathematics, and that leads to a lot of problems. So with respect to that body of evidence, massive body of evidence, catalyzing change is dealing with a real problem, and in its recommendations for more focus, it's very consistent with what the Common Core was trying to do. It's bolder. The Common Core, we did not specify courses in high school, and therefore we did not specify pathways. So NCTM took up that challenge and made these recommendations. And so that is not in conflict with the Common Core. It is a very strong and I think valuable recommendation for how to organize courses and pathways, and in particular for whom the courses should be designed. Now I'm going to step away from the Common Core perspective and speak more openly from my own experience, which includes the Common Core, but includes working with high schools, high school teachers, as well as districts, states, and schools. The long history of mathematics in this country, and that persists still to this day in the culture of high school mathematics, is a history of using mathematics to filter students and for having the curriculum designed for some and flunking the rest. Or if not flunking, faking them out, giving them fake Bs and enrolling them in courses that have the right names but are really kind of fake courses. And every high school teacher and high school department knows this, and none of them like it, but it's the condition that they all have to respond to. And that's what I think many of us are trying to change, and catalyzing change is trying to change. Bob referred to it as using math as pedigree. The key recommendation that's being made here, and I think a very good one, and one that's similar to what they actually do in many of the high-performing Asian countries, is to design the common courses for everyone. Do not design them for STEM intending students. In other words, the curriculum needs to be designed for everyone, not just for some. If a course is designed for students or intending to specialize, that's a specialized course. It should not be required of everyone. It should be required of those who want the opportunity to specialize, in this case, in STEM. So we don't have any problem with that K-8. The K-8 curriculum is designed for everyone. 8th grade is designed for everyone. Where does designing for everyone stop, and where does specialization begin? That's a tough problem for math. It's going to happen in high school, and it has to be solved for the whole system, not having the broken system we have now. So the way Escondido solved it, because they've been operating for a number of years, the way Oregon is thinking about it, San Francisco is another district, is to begin the specialization in the junior year, which means the freshman and sophomore years are courses designed for everyone. So I just want to pause for a minute. What does it mean to design a course for everyone? And just as a wake-up, I'd like to recommend that you look at Jal Mehta from Harvard's recent study of American high schools. In fact, there's an article in the Washington Post that kind of summarizes it, titled, "A Startling Tour of Empty-Headed Classes in Much Praised High Schools." So they studied highly praised high schools, and when they actually went in there and looked at what was happening, and math was the worst, what they found was empty-headed classrooms of empty-headed time. And it wasn't because teachers were empty-headed, and it wasn't because that's what they wanted to do. It was because of all these problems we're talking about today. It's very grim, and math is very grim. Why should it be that way? It doesn't have to be that way. And we want to change the conditions so teachers can make the course more engaging, more exciting, and more relevant to future English majors, video game makers, and most of the jobs that are out there. So one of the ways that this is possible is by shifting to have more emphasis in high school on functions and correspondingly less emphasis on solving equations. Both things are good things, but how are we going to spend our time, and how technical are we going to get? How technically demanding are we going to get in the course designed for everyone? It's in the nature of functions that the early intuitive understandings of functions, while not mathematically precise, are more or less in principle the right idea. In fact, they reflect exactly how the mathematical concept of functions evolved historically. And functions are much more intuitive. A lot of the work with functions is about the correspondence between a function and the real world situation that it's modeling, and about the correspondences across representations, as we saw in Bob's example. Whereas the solving equation perspective produces a lot of abstract technicalities that require algebraic gymnastics. When you work with functions, you do not do a lot of manipulation of the algebraic expressions and structures. You're mostly interpreting them and constructing and formulating them to match the conditions that you're trying to model. So this is a core, maybe the most important example of what it means to shift the emphasis in the curriculum so that it's a little deeper, and in going a little deeper, you're also less technical, more intuitive, more relevant for more students. And just in passing, calculus, which everyone's so worried about, is the real title name of that course is the analysis of functions, which you're studying in calculus and pre-calculus and all the courses that ensue is functions. So I just want to finish up by getting back to this key idea and invite people to react to it, of having common courses designed for everyone, not for STEM majors, followed by specialized courses and pathways where students can choose to go in a STEM direction or in another direction. The other condition of those pathways is that every pathway leads to opportunity. So in simple terms, every pathway leads to college eligibility, but every pathway does not necessarily lead to preparation for STEM. And implicit in all of this is that these are pathways are options that students choose rather than placements that schools make. And that's what makes it different from tracking. So I'm going to leave it at that and invite Bob to comment on any of my comments on his comments.
Great, and we also have a bunch of questions coming in, so I'll throw them in after Robert speaks.
Well, let's see. Okay, I was checking. So my comments is related. I actually support all of what you said, Phil, but the key thing I want to kind of add in is also thinking about, those first 2 years of high school mathematics. It's really, what are the things that we know that all students should know and understand? And that's where we should have a discussion. Again, NCTM identified 41 essential concepts. There may be fewer, there may be more, but it is those 41 essential concepts should be in that common pathway. And those are the things that, as you mentioned, they're not specialized. They are really for everyone. And that's where I think we really have to have a conversation about. Also, I mentioned the idea of tracking. NCTM is also engaging in the process of catalyzing change. This catalyzing change focuses on high school mathematics, but in April of 2020, we will have catalyzing change for middle school and catalyzing change for early childhood and elementary. And so we'll look at those recommendations, how those recommendations play out similarly and differently across the K-12 grade bands. And so we will have similar conversations for elementary and middle school as well, because to detrack in high school, you also have to have a conversation of what happens in middle grades and elementary grades as well. Okay. So we are going to take up that conversation as well.
Okay, great. So we have a bunch of questions, and some of them are focused around this idea of the central concept, the idea of a common pathway in the first 2 years of high school. So one question has to do with accelerating, I think. And I know catalyzing change draws a distinction between tracking and appropriate acceleration. So there's questions around that. But the question that came in from Connie Richardson actually is, does this mean there wouldn't be pre-AP courses in the first 2 years of high school? So can you speak to that, Robert, and thoughts about how acceleration is appropriate?
So in catalyzing change, we do make the distinction between tracking and acceleration. And again, with the focus on a common pathways. And so, we make the distinction that no critical concept should be skipped or rushed, that all students will progress through that common pathway. One could accelerate through the common pathway, but not skip the common pathway. And so it could be plausible that all students are entering this common pathway. Some students may accelerate along that common pathway. So does it mean, the question about AP, one thing that we have not talked about is what would those courses be in early high school mathematics. We're making the case that early high school mathematics should focus on the essential concepts. And some of those things that might be within those essential concepts could support, and I would argue would support some of those concepts that are supported in some of the early AP courses in high school mathematics, particularly with an emphasis on functions, particularly with the emphasis on some of the statistics that are in the common pathways that could be supported in the pre-AP courses as well. But we don't make any kind of recommendation about a course, rather it is within that common pathway around the essential concepts.
I'd like to just add a couple of things. I think there's high costs and lots of risks and dangers in accelerating early. And accelerating in 9th grade, when the kids first come in, before they've had a chance to know the teachers, et cetera, is more dangerous than it's worth. And I would urge people to accelerate later rather than earlier. Certainly no earlier than 10th grade. There's time to accelerate. The other point is we should spend more time on the most important topics. Right now we're spending time based on the difficulty of the topics. So a relatively unimportant but difficult topic gets more time than a very important but easier topic. And the results show when the students reach the university and are enrolled in an advanced calculus class because they got their 4s and 5s on the AP exam, but still do not understand the distributive property. They rush through Algebra 1, which is actually more important than some of the more advanced topics. So advancedness is not importance. Difficulty is not importance. Importance is importance. And that's where we should invest the time.
Thank you both. And I want to move off this topic of acceleration, but we did get a comment in that, acceleration doesn't necessarily need to be about speed. It could be about complexity or depth. So that's another way of thinking about it. But I want to move on to another question. We have an English faculty member on here, Katie Hearn. She's very interested in this, and she's wondering, would the earlier, she just wants clarification, these earlier courses would reflect current Algebra 1 and 2 curricula, but are you advocating for streamlining the topics here to allow for greater depth and less overwhelm? Which is, I think the answer is yes, but I'd like to ask Robert to speak for NCTM on that.
It is the latter. It definitely is the latter in terms of thinking about, the essential concepts. So there's some overlap, but, there is this focus on, some of those big ideas in geometry, statistics, and algebra and functions, as well as numbers that would be covered in the essential concept. And so while there is some overlap with Algebra 1, the focus is really on those essential concepts. So I'm actually, so it is going to be disruptive in the sense of thinking about, if we can think about what are the critical things that kids should know and understand, rather than our current packaging of courses, that moves us to think differently. And if we can think about what are those key concepts that kids should understand, then we can think about courses later. But if we can agree on what those key things are that kids should know and understand, then and move away from our thinking around current courses, I think that will serve us well.
I think that Common Core, I'm stepping in, and Phil may want to say something, but I think Common Core Math was trying to do that by suggesting there may be more pathways, and what NCTM with Catalyzing Change is talking about is taking that farther. I hope I'm saying that right, Phil?
Yeah, yes, and it's also, it's a common misconception that the content of Algebra 1 and Algebra 2 is stable and consistent. It's neither stable nor consistent. There's wide variation in what different schools call Algebra 2 and what call Algebra 1. And both of courses have changed, but they've changed in a very willy-nilly, haphazard way over the course of half a century. And they're still heavily loaded with freight from the 19th century. They never really digested the 20th century, and here we are in the 21st. So they've been in need of updating and attic cleaning and making into coherent courses for a very long time. So the Common Core made an attempt for the high school curriculum as a whole, but it didn't define a course. Catalyzing change, it gives people an important tool for understanding what the priorities are when you're going to spend more time on some things and less on others.
Okay, now another important question we have here from Amy Getz at the Dana Center. When you talk about the junior year as a point where students are taking different pathways, pursuing different pathways in math, what kinds of structures or processes would help ensure that students enter or select into the different courses in an equitable way, and that the decisions are not based on perceptions, bias about race, gender, socioeconomic status? And I would add, this is obviously particularly a concern because of sometimes students internalize biases of others or based on their educational experience, and how can we make sure they're making, to the extent they're making choices, that they're making, you know, aspirational choices for themselves. Thoughts on that, Robert?
So,
or Phil? Go ahead.
My thinking around those issues, so when we think about those pathways, and I'll use Oregon as an example. There's a pathway that feels very traditional in the sense that students can continue on calculus, but then there's a pathway that focuses on statistics, and one could argue that might focus on in the areas that situate with regards to humanities, and there's a CTE pathway, career technical education pathway. And so these pathways might be focused on students' future endeavors and how they see themselves, and they become a little bit more specialized. And so by the student's junior year, there may be they may be capturing their interest in terms of moving forward. But it also creates the opportunity for us to think about, well, what courses in those pathways should be available as students move forward. So we may have to push the idea of what a math course is, and then rethinking some of the content in those math courses, or thinking about something beyond traditional math courses that will be available that will capture students' interest in terms of how they see themselves in their future area of study. I'll defer to Phil.
Yeah, I think that's a very good question, and I think you defined a very real problem. And I think we will be ahead of the game if we exchange the current problem, which is schools placing kids in tracks from an early grade level, for the problem you raised. And for the problem that you're raising, we're going to have recruiting strategies, academic youth development strategies, and we're going to have to put mechanisms in place in the school to work with the kids in terms of their identity, their agency, and their aspirations. That's going to have to be the positive programs, not passive programs. So that's a problem that we're going to have to solve, and we should solve. That's one we can get our hands on and grapple with, and that's where I'd like to see us get to. It's also a reason for making the specialization occur later rather than earlier. And that, I think, is not an easy thing. It's debatable. Some would say start the specialization in 10th grade, which would be 2 or 3 years later than we're doing now. and many say start in 11th grade.
Okay. I want to move on to another question. This is from Kimberly Seashore at San Francisco State. She's interested in the issue that NCTM raises about tracking of teachers, and the idea of high school teachers teaching both entry-level and advanced courses, and leading to diversity in the teaching force and giving teachers a broader perspective. Kim is saying it makes a lot of logical sense, but she's wondering if there's been empirical research about the efficacy of it and whether a case could be made also for having teachers who actually have expertise in meeting the needs of entry-level classes, or is there a concern that teachers who teach both entry-level and advanced might pay more attention to students in advanced courses? So she's just wondering if we have any data on this, or do we need some more research on it?
Great question. And so one of the things that come to my mind is when we think about, I guess currently in our current structure, it raises the question of the least experienced people being in the entry-level courses, and the more experienced people teaching the higher level courses. And so so the students with the highest need may have the least experienced teacher teaching them in those entry-level courses. With regards to the issue of research, so in Catalyzing Change, we cite 3 studies. We cite a study by Linda Darling-Hammond that was done in 2007, and I can, I guess, Pam, I can send that to you.
Yeah, you can send that to us.
There's also a study that was done by Marilyn Strutchins, and Judith Quander and Rochelle Gutierrez, that was done in 2011 that we cite in Catalyzing Change. And also there's a paper that we cite in Catalyzing Change from Tyson and Roska, in which we cite as well, that speak particularly to teacher tracking and the impact on teacher tracking and student outcomes.
Thank you for that. And for those of us in California, Linda Darling-Hammond is now heading our State Board of Education, so she's definitely on our radar screen.
So there's also Susanna Loeb has done a lot of work in general, not in math, on assignment of teachers and, and who teaches whom.
Yeah.
Hi, Kimberly.
Good question. Okay, now, Ricardo Moena from Ohio is here, and he's asking about basically alignment with higher post-secondary education. So if the well-defined pathway would begin in the junior year of high school, and as you know, post-secondary is working on also defining math pathways. So do you envision a simplification of the admissions process to colleges? Ideally, colleges the colleges that are working on constructing guided pathways, these should connect smoothly with the high school path. Any thoughts on that?
Yes, I've been in this space between, and as Pam has even more so, as we go from K-12 to higher ed. And there are so many different institutions and bodies and committees and panels that have jurisdiction over different aspects of this. It's all too easy for it to be a situation where, oh, I'd like to fix it, but I can't because they have to fix it first. And I think we have to break that logjam. And the only way to really break it is for everybody to act. And if we all act on common principles, we'll wind up with something which is somewhat of a mess, but which will be fixable and revisable. So nobody should wait for the other people to do their part. Every institution should do its part. Then we should see what the mess is and fix it, because it's going to be better than what we've got now.
Okay, it's a better mess.
Yeah, it's a better mess than the mess we've got now.
Okay.
And I think that the higher ed is moving in the same general directions to solve the same problems. So I think there's going to be some accidental harmony in it. And some projects like the Dana Center's been doing on the pathways from upper high school to lower college. Some of that work is going to have a lot of influence and save us a lot of heartache.
So we have a question from Stacy Snyder, who I don't know, but she appears to be a high school math person. And I was actually initially going to ask Robert about what the response has been to the report, but what we're hearing from one high school saying that they're in the process of changing their math pathways so that all students take Algebra 1 in 9th grade and not in middle school, and that they've used Catalyzing Change quite heavily as a resource. But Stacy's wondering, do you have a toolkit or other resource that she can leverage as her school is transforming how teachers and parents think about this change? She's saying most stakeholders are on board and happy, but not all. And so what tools or strategies do you have to help them get more people on board?
Great. So thank you for that question, Stacy. There are a couple of things I can point you to. One, right now, if you go to nctm.org/change, you will find on that website, you will find right now there are 4 case studies. And Escondido is one of those case studies where they talk about the process in which they have undergone to move through detracking and the courses and designing of their courses. And they talked, in this case study, they talked about a 5-year process they've taken. There's also a case study that's focused on the work that happened in San Francisco Unified, and they described a similar process that they went about. So it provides some context for the work that some folks have done. There's also a case that, there's a third case that focused on how the state of Colorado has incorporated the essential concepts in their revision of their mathematics state standards, and it's the Colorado 2020, and that it's actually been passed already in their state by their state legislators. And then there's a fourth case that focuses on what's happening in Louisiana as it relates to pathways and Algebra 1. And so I think those cases are cases that you will find valuable. Some upcoming things that will be valuable. We also have we're hoping that later in the academic year, or even in the fall, early fall, we have an administrator's guide that will come out that will focus on catalyzing change. The questions that some of the barriers or some of the challenges that administrators may have in terms of dealing with some of the issues that we raise with catalyzing change, and ways that they can handle and deal with. So in that text, there will be vignettes around the 4 recommendations, as well as some kind of checklist and things that can be actionable in that moment. So there's still things coming forward and a lot of work around that. We also have another thing that we're doing with regards to actually higher ed, in terms of how do we see pathways connecting to, the first year of 4-year and 2-year colleges. And so we have a document in terms of how to map down from, your first entry level in the 4-year, 2-year colleges down to your last course in high school mathematics, and how do those things kind of connect together. So there's still things under development, and we're still working through some things, but yeah, I would say the first step was take a look at those 4 cases.
And just for stakeholders who aren't in the math community, I've always found that examples help. And the 2 contrasting examples that Bob showed, if you just earlier in the slides, which will be available.
Yes, they will be available.
If you show those 2 examples and say, we're going to spend more time in problems like these and less time on problems like these. Mm-hmm. And the SAT has certainly shifted its emphasis, so it does not have problems like that one. Not that it actually ever did. It had much simpler versions, so it has more like the other one. So that's a good way for regular people to understand what the shift is.
So good points, both of you. By the way, Stacy just told us where she's from, Highline Public Schools near Seattle. Thank you, Stacy. And we have, since you talked about folks from outside the education, who don't work in education and work in math, we have a question from Karina, who's with Public Advocates. This is an advocacy organization based here in California. She says, these pathways sound like a great approach. I wish I had this option in my high school education. I'd like to hear more about any organizations, institutions, or stakeholders that have come out either supporting or opposing the recommendations, and or what other key feedback you've received, I think, from, sort of influential organizations, et cetera. Can you respond, Robert?
Yeah, I can. So most of the feedback has been relatively positive with regards to thinking about the essential concepts and even thinking about a common pathway. And so, as I mentioned earlier, Escondido, San Francisco Unified, there has been, so I will say in Alabama is going through a process right now where they have put forward a standard course of study, but they've received some pushback, and they've called for detracking in terms of going to a common pathway from middle school through the first 2 years of high school. And there's some political pushback in that space, and their pushback is relatively to the kind of, they took a geometry first approach, and so that pushback has been more along content and less around the kind of the concept of essential concepts and the common pathway. I know Baltimore County Public Schools is exploring and in the process of developing this idea around common pathways as well. So there's been some energy, nationally with regards to common pathways and essential concepts. We're only, it's only been a year since we published this. And so I still think we're in this phase where folks are still in the process of discovering, catalyzing change. But for the most part, the reason why we decided to go with an elementary and early childhood elementary version and a middle school version was the response, like, so what happens? What do we need to do before high school? And so as people discovered the catalyzing change for high school, it then pushed us to have a conversation for early childhood, elementary, and middle school as well.
I think the tracking issue is not a good way of framing this whole discussion, because tracking, well, isn't evil, but fear of tracking is also paralyzes people and disables the conversation. There is a real condition, a real issue, and a real problem for math teachers and math departments, which is that kids are different. They have different levels of preparation, they have different aspirations, different academic personalities. You can go on and on. And other subjects like English or social studies deal with those differences in a way that more or less works for them. Their curriculum is designed so that kids who are different can all work on a similar assignment, produce different products, and everybody survives and moves on. In math, because it's designed superficially to produce answers, everyone is required to produce an identical product. Everybody has to produce X minus 1. From the top student to the least student, they all have to produce an identical product, which means the differences between the students are transferred from the product that you produce to how long it takes to produce it and how consistently you can produce correct answers, et cetera, which is completely unworkable. And that's where all our problems are coming from, and that's the inch deep issue. We need to change the kinds of products we assign students to produce, that where it absorbs more of the differences. Tracking is an evil solution to a real problem, and we have to get rid of the evil solution. And then when we do, we're back to the real problem, which still needs a solution. And offering students pathways, specialized pathways, is a better way to deal with their differences. As long as every pathway leads to real opportunity, and every pathway has quality programs and quality teachers, and the kids are choosing their pathway, and as was it Katie that pointed out, we're going to have to recruit kids into the pathways.
Amy.
Amy, yeah. We're going to have to have systematically and positively recruit kids into all the pathways.
And yes, and I think we're at time. I think that catalyzing change is going to certainly help people think about this, how to go about it. I want to say that Just Equations is coming out shortly with some equity principles that are going to, sorry about that, slide problem.
Just take your finger off. There you go.
Some equity principles that are going to also help illustrate how this can be done. And I'm sorry we have a little trouble with our slides, but our final slide has some resources on it to share with you. We had a question about the article Phil cited, and we'll try to get that sent out to everyone. I want to thank our panelists and our participants. This was a very rich conversation. Thank you all for being part of it. And we look forward to continuing the conversation with all of you. Thank you.
Good. Thank you.
Okay.
So we're off the air.